I'm Kim Combs. When it's grade card time, your teacher looks at the record of your past grades to determine your final grade. The record that is kept, be it on computer or gradebook, tells how you performed over the last grading period. Records are kept about all kinds of things: finances, sports, health, you name it. You even keep record of what substances have entered your body, whether you know it or not. So what's chemistry got to do with it? It's all in your hair. That's right, your hair. The hair on your body, particularly your head, is a pretty good record keeper. In fact, it is so good that forensic scientists rely on it to provide evidence of the presence of toxic substances, poisons, or drugs in a person. Hair also has characteristics that can determine the race of the donor, if the hair has been dyed, if the hair is human or animal, even what species of animal left the hair behind. And if the hair has a root or follicle attached, which happens frequently when hair is pulled out, DNA testing can be done. To investigate more issues like these, we talked to forensic scientist Suzanne Bell.
Until the advent of reliable DNA testing techniques for hairs, really all you could say was this hair could have come from a person, or it definitely did not come from a person. You could also identify a hair as a cat hair, dog hair, that kind of thing. Forensic science is principally a science of comparison. Our job isn't to identify it as hair so much as to say, could this hair have come from this person, or did it definitely not come from this person? So you always have what we call a question sample and a known sample.
Not all hair is alike. Human hair can be broken down into 3 racial categories: Caucasian, European origin; Negroid, African origin; or Mongoloid, Asian origin. Human hairs are also distinguishable from hairs of other mammals. This is done through pigment, scale type, and medulla characteristics. Even with these identifiable characteristics, scientists can only be certain that a hair is similar to another.
What can be very useful are the combinations of hairs that you find. For example, if you find both cat hair and dog hair and maybe goat hair, for example, that might indicate that this person is at a farm or has contact with a farm, and that's what we call good investigatory information. But it wouldn't necessarily, you can't use a hair and say this hair came from that person without DNA.
One of the hardest parts about gathering hair evidence is determining what hair is important and what hair is not. Hair can be found just about everywhere if you look hard enough, and collecting and testing it all isn't practical. So the people collecting the evidence have to be well-trained and selective. Hair can provide some other important information, though.
Where hair is finding more use is in toxicology. It's a whole different idea there. It's trying to recreate what somebody took at a certain time or was given at a certain time. It's been used for poisons. It's being used increasingly for a lot of drugs to determine if somebody took a drug 3 months, 6 months, or even weeks prior to that, because the hair, once it's trapped in the hair matrix, it's isolated from the body's metabolism and circulation, so you have, in effect, a frozen record that moves out at a known rate, roughly a known rate of time.
Let's take a look at how hair accumulates a record and how scientists go about retrieving that record and reading what it says. Hair is made up of 90% protein called keratin and 10% water. Hair grows quickly, about a ½ inch a month. Every ½ inch of growth roughly equals a 30-day period. The hair closest to the scalp is newer hair growth, recording the last 30 or so days. The longer hair gets, the greater length of time it records. For instance, if a person's hair is 3 inches long, the ½ inch of hair at the tip recorded any substances present in the body 6 months ago. When a substance is introduced into the body, it is carried by the bloodstream throughout the body structure, including the hair. Molecules of the substance enter and get trapped into the hair matrix. Over time, the trapped molecules move out with the hair as it grows, creating that frozen record talked about earlier. After a sample of the hair is obtained, it is measured and washed to remove impurities on the hair's surface. Next, the hair is dissolved in an acid for several hours. Once dissolved, the acid is removed, leaving the substance to be tested. The substance can be analyzed using a gas chromatograph mass spectrometer, or GCMS. In the GCMS, the substance is converted into a gas, which is broken down into its parts. Think of it this way. The substance being analyzed is like a cup of fruit salad. The GCMS separates and measures the different components of the substance, like separating and measuring out different pieces of fruit in the cup. The GCMS can detect trace amounts of a substance, even as small as 1 part per billion. Hair is being used more and more for drug screening by employers. It is much easier to collect a hair sample than a blood sample. Hair sampling is considered to be non-invasive, just a painless snip and it's over, versus a blood draw, which involves a needle, requires a nurse, and takes more time. Not to mention the time span that can be covered when testing hair. Our hair has an amazing ability to collect and store information about us, and techniques like hair analysis, coupled with technology like gas chromatograph, mass spectrometry, are unlocking that information for scientists to use. See you next time.